Hello everyone, my name is Nishit Chaudhary and today we will be learning how to design a Turing machine for a given language. This is part of theory of computation. So here the language is a power n, b power n, c power n, where n is greater than or equal to 1. So for example, let us take n is equal to 2. So the string would be AA, BB and CC. So how we will start? First of all, we will convert this A into X. Then we will move right till we get the first B. So we will ignore this A and move on to this B. So when we reach B, we will convert this B into Y. And similarly, we will move towards the right. We will ignore this B and when we reach the first C, we will convert it into Z and then move left. We will keep moving left till we reach X. So when we reach X, we will move right and we will convert the first A into X. Similarly, after doing that, we will move towards the right, ignore this Y, and then whenever we reach the first B, we will convert it into Y. Then we will move towards the right again, and then similarly continue the process till we reach C and convert this C into Z and then move again toward the left. So as you can see here, no A, no B and no C are left. All are converted into X, Y and Z. So this string would be accepted by the Turing machine. Now let's see in detail how to do this process through a transition diagram. Learning it through a transition diagram would be somewhat easier. So let's start. Our initial state would be Q naught. Here the Q naught, in Q naught, when we encounter A, the first A, we will convert it into X and then move towards the right. So this would be converted into X. After moving the pointer to the right, we will keep ignoring the A's which come. So let's first move towards the second transition state, Q1. Here we will ignore all the A's, we will keep them as it is and keep moving towards the right. After that, when we encounter the first B, we will convert that B into Y and then keep moving towards the right. So the next transition state would be Q2. Here, similarly as we have been doing, we will keep ignoring all the B's that come after this one. So we will keep them as it is and move towards the right. So when we encounter the first C, we will convert it into Z and then move towards the left. Okay, so then let this state be Q3. After doing this, as you can see, we move towards the left and we will keep moving towards left till we encounter X. But we won't change anything, we will keep X as it is and then go right. Here, similarly, when you encounter the first A, you will convert it into X and then keep moving right. Then if you encounter another A, you will keep it as it is and then move towards the right. Or what can happen? You can encounter a Y. As we converted this B into Y, when the pointer was here, this B was converted into Y and this C was converted into Z. So for the second time, when you start from here, you converted this A into X, then you will ignore this A as you can see here and move towards the right. Then you will encounter Y. So we won't make any changes. So we will ignore this Y, keep it as it is and then move towards the right. Then when we move towards the right here, we will convert this first B into Y, then move towards the second transition state Q2, the third transition state Q2. Then we will ignore all the other b's that are left. So here the b is left. Also we will need to ignore all the z's. So z will be ignored, and then we will keep moving towards the right. Then when you encounter c, convert it into z, and then move towards the left. So now when moving towards the left, you will encounter all these different variables, but you have to keep ignoring. So you will encounter z, keep ignoring, move towards the left. You will encounter b, keep ignoring, move towards the left. You will encounter y, ignore that also, move towards the left. And similarly for a, move towards left till you get x. Then again for this one you will convert this into, okay, you will convert this into x, then ignore this, then convert this into y, this into z. Okay, the string is over. Now what will we do? So from here you will see, as you have converted all the a's into x, so here there will be no a. So what will you do? So from here you will go to another transition state, q4. For y you will keep it as it is and then convert, so go towards the right. So here from q3 to q0, there is no a, there will be y. So when you go toward y, keep it as it is and go towards the right. So what happens when you come across another y? You don't change it, keep it as it is and move towards the right. Similarly, you will also encounter z. Don't change that too, keep it as it is and move towards the right. So when you keep doing this, you will reach the blank b, keep it as it is, and here it doesn't matter you move towards the right or left, as your string will have already been accepted when you reach this point. So this will be your final state, q5. So this is how you can make a transition diagram for a string a b b b c c c, which is a part of the language a power n, b power n, c power n. So now let's see if it works or does it not work for any other string. Now let us take a a a a b b b b c c c c. Okay, so here n is equal to 4. So what will happen first? First the pointer will be at a. So we will convert this a into x and then keep moving towards the right. We will ignore all these a's, as you can see here. Then we reach the first b, we will convert it into y. Then keep moving towards the right, similarly z, and then go towards the left till you reach x. Okay, so here we will reach here again, and then we will go towards the right. The first a we will convert it into x, so this a will also be converted into x. Similarly this y, z, again repeat x, y, z, then again left x, y, and z. So here you will reach q3, so you will move towards the left. So when you reach x, here as you can see there is no a. So what will you do? There are only x's. Now when you reach y, you have to go towards the right. So you go towards the right in transition state q4. Here y, again right, again y, again right, and then right. Then you reach z. Similarly here you will keep moving towards the right, and as you can see after this there is nothing, so this means blank. So you have reached blank, that means you enter into q5, which is the final state. That will mean that given string this string is accepted by the Turing machine. So now let us see the table for Turing machine. This is the table. As you can see, this is similar to the transition function. Let's say here the first state is q naught, so you will move into q1 while converting the a into x and then move towards the right. Then you will move to transition state q1. Here you will ignore all the other a's. See, q1 a r. So when you reach any other a in q1, you will keep ignoring them and move towards the right. But when you encounter the first b, you will convert it into y and then move to transition state q2. So here there will be no a. When you here in transition state q2, when you encounter any other b, you will keep them as it is and move towards the right. And when you encounter the first c, you will convert it into z. Now from here you will move towards the right. Sorry, it's my mistake, you will move towards left. And similarly this process will keep continuing as we explained in the transition diagram. Here the same process will be is happening here, but it is written in a tabular form. Now let us write the formal representation of a Turing machine. So what will it be? So at first you have to write Tm. So first you have to write all the transition states: Q0, Q1, Q2, Q3, Q4 and Q5. After that you will write all the set of input symbols A, B, C. After that A, B, C, X, Y, Z, B. This is set of all these. After that you will write transition function delta. Delta has been written in a tabular form. After that you will write q naught, which is the initial state, then blank, which is B, and then set of final state, but in our case it is only q5. So this is how you write the formal representation of a Turing machine. So now that you have understood how to design a Turing machine for the language A power n, B power n, C power n, and this process will stay similar for all different kind of languages, and you will be able to design Turing machine for A power n, B power n, A power n, B power 2. So you will be able to design Turing machine for all these languages. I hope you understood this. Thank you so much.